Thank you very much. My name is Niklas Hus, and I'm from the University of Wismar at the beautiful Baltic Sea. And our topic is the migration of an embedded system to Zephyr, an embedded systems lab. And yes, I will start by introducing our university, the different courses we have on embedded systems, talk about the hardware and the software we were using until now and are using in the future, why we choose Zephyr, and the labs we did to apply Zephyr, and conclude, of course, what worked well, what didn't. And yes, our university pictured here is we have different courses on microcontroller technologies, starting already in the 4th semester of the bachelor's curriculum, where we teach the basic microcontroller concepts, the periphery, I/O, counters and timers, stuff like that. There we program in assembler and C. In the Embedded Systems 1 course in the semester 6, we are we're only programming C and C++, doing sensor and actor integration, and also control technology, and model-based development, because we have different students from mechatronics, informational technologies, and electrical engineering, and also with a specialization into automation engineering. The model-based development is interesting for them as well, using Simulink, for example, with our embedded coder for Embed OS, which we used until now. And yes, embedded control systems in the master's semester, as well as embedded systems 2. They dive more into advanced control technologies, and also IoT is a big topic in these courses. Yes, embedded systems 2 is more into secure and unsecure communication, and micro and circuit Python for programming. So like I said, we also, like one of the presentations before, used Embed OS until now. Because of course it's open source, there was a continuous development going on up until a few years ago. And some of our colleagues also contributed heavily to Embed OS and had a high level of experience. So it was natural for us to use it, because also it worked well. The students got it fast. Yes, but unfortunately, Embed OS is soon hitting end of life. It was announced last year officially. There is the community edition being continued by the community on GitHub, but we wouldn't want to teach the students something that is officially dead. Yes. So yeah, here you can also see the the history of the contributions. So what we did and what we're doing is that we're using custom hardware. It's based on an application shield, which was developed for Embed OS projects, but we changed it up. You can see it here on top of a STM32F7 controller. Here it is alone. And yes, what can we do? We have different buses on there. We have UART, SPI, I2C, obviously digital and analog out for the students. We have an RGB LED up here. We have a NeoPixel LED down here. A piezo buzzer over here, which is fun in the lab when 8 of the students try to play the Imperial March on it. We have a display, of course, for setting up something like a basic user interface, menu navigation with this navigation switch down here. And some sensors. We have a temperature sensor on the board, and we have a connection for SDS-011 particle sensor, which is used in many of the IoT projects, for example, for measuring the environmental the particles in the environment and the quality of the air. Yes, here you can see the schematics, which are also on GitHub if anyone's interested. So what we did, we always, obviously, the hello world of embedded programming for students that sometimes never heard of embedded programming or were taking the first steps. We did a Blinky with EmbedOS. Then we used the application shield components like the analogs, the digital in-outs, PWM, and I2C. Then we had this command parser project where we used hterm or teraterm to input command line strings to maybe set up some program on the microcontroller, input parameters for different, like for a controller, for example. And we also took advantage of the networking in EmbedOS, which worked well. And with this, we set up some projects on ThingSpot and on ThingSpeak, which are both IoT tools, where the students would send the data and maybe then later evaluate the data in MATLAB as well. And obviously, we were also teaching the RTOS capabilities of EmbedOS. And yeah, in the end, we had the model-based development. So here you can see on top, basically just a Blinky in Simulink. So we have a PWM, a converter block for the right data type, and then the LED of the microcontroller as a fixed block in Simulink. And on the bottom, you can see Stateflow, which is a tool for state machines within Simulink, kind of like a subsystem with a different language, where we used Stateflow to read out the packages that are coming from the SDS 011 particle sensor, going step by step, and in the end, calculating the real values of the different particles that are detected. So obviously, because EmbedOS was dying and we had to find a new way of setting up the labs, we ended up with Zephyr, because especially during visits in Nuremberg at the Embedded World, we noticed the shift to Zephyr for many large manufacturers. We visited workshops with NXP and AD Instruments. And yes, we got the impression that they are very confident in Zephyr and contributing and continuing Zephyr. So these were the experiences that led us to choosing Zephyr. We also had a very good master's thesis using Zephyr for secure communication, which also influenced that decision as well. So for the last year, the last semester, the structure was like this. We had the basics of embedded systems with I/O and drivers and sensors and actors with Arduino, which worked well with all the students. For each of the frameworks, we used projects to enable the students to work by themselves and be active, do problem solving without someone looking over their shoulder. And we try to teach that as well, to know where to find the resources, where to find examples, and how to approach a new project. Then after Arduino, we got to Zephyr, starting with the basics like the device tree, the configuration files. Because myself, I was working in a project using Yocto a couple years before, so I was familiar with the device tree, and for me it seemed intuitive, but for most of the students it was not intuitive at all. So we spent some time on that. And in the end, like I mentioned, the model-based development in Simulink. Yes. because we switch between these different frameworks, we use something called platform I/O. Sorry. So maybe some of you have heard of platform I/O. It's a VS Code plugin for switching between different frameworks, for also setting up the framework on the system, because many students, they use their own laptops, and we wanted to keep this setup as easy as possible because, like I said, they are not all informatics students. They might be mechatronics students or electrical engineering students. So that was the easiest way to achieve that. At the time of writing of the paper, it was using version 4.1 of Zephyr. And here you can see the overlay. It's pretty easy to start new projects. And yes, all the background work is set up by platform I/O. Yes, and then the hardware we used obviously had to be tested with Zephyr as well. For that, we develop a kind of a hardware test program to validate the capabilities of Zephyr and the hardware, using all the sensors or the actors on the board, which was later then also handed out to the students as an example on how to work with Zephyr. Also found on our GitHub. So yes, how did we approach Zephyr as educators? After using Arduino or also even assembler-based programming on embedded systems, the students were obviously familiar with coding. They knew what GPIO were, what drivers are, and how they are applied. And we used the knowledge they already had and introduced the new concepts to them, like the device tree, the config files, and how to write code in Zephyr. And yeah, RTOS, obviously multi-threading, why it's important, and how it works. Yes, like I said, we started by introducing them to the device tree. We made them write nodes in the device tree as well to get them have a feeling for how the device tree works and what it is. But in the end, obviously, for the big for the whole board, we supplied them with the device tree. And yes, the config, of course, as well. And in the end, the labs kind of looked like that, like this. We started with the device tree and the kconfig and the project conf, all that stuff, and made them use like the simple stuff like buttons and LEDs, and using the analog digital I/O. Then we made them familiar with the device drivers, because we didn't have a device driver for the display we were using. We had to adapt one, which was a good example and a good practice as well. And in the end, we gave them a project to solve as also a part of their final grade. So yes, the final projects I mentioned, there were three kinds of projects to choose from. One time it was an environmental sensor using temperature and the particles in the air. The other one was a reaction game with the navigation switch, different colors of the LED, and scorekeeping and rising difficulties, and also a kind of a simulated controller for temperatures, using the temperature sensor and the RGB LED for simulating heating and cooling. The students were allowed in the end to choose a framework to develop their project. And kind of to our surprise, pleasant surprise, most of them use Zephyr, which is good, I think. And yes, what we learned in the end is that having this custom device on hand that we developed as well, that we understand very well, is fundamental to teaching. Arduino was a good gateway to teaching the core concepts of embedded development. And we will probably continue using Platform IO. And yeah, the coding itself, why it takes a lot of time in the labs, is not what we have to teach. It's the framework, the concepts around it, that's more important to teach the students. Yes, one problem we often had when also developing the device tree was that the students were typing down what we were typing on the big screen. There's a high potential for mistypes, which are sometimes not instantly obvious to find as well. And yeah, in the future we will definitely have more time for the device tree, for Zephyr itself. Probably also have a higher number of labs to better convey all the core concepts, to get them to work more on their own with that. Yes, we thought about applying like functions for handling all the repetitive code, like when you're using many different GPIOs. You have a lot of repetitive code in there, and yes, like I already said, we develop more time for Zephyr development and focus more on the device tree and the configs as well. So yes, in the end, we decided that we will continue with Zephyr, and yeah, that the students, while at the start they had difficulties, it wasn't that easy for them to grasp the concepts. In the end, they had fun with it, and so that was overall a very positive experience in the end. Yes, thank you very much for your time, and please ask your questions.
So, any questions? Don't be shy. Yep.
Do you plan to skip the Arduino part completely at some point, or do you think it's necessary for the basic concepts?
I think I thought about that also. Maybe minimize it to 1 or 2 labs, but I think it's important for getting like the core workflow, you know.
Maybe I can add something, because I have the next round next week with computer science students. So they never work with embedded systems. So Arduino is not nice, not for real projects, but for a student who never programmed a microcontroller, it's an ideal start. EmbedOS was an ideal start because it was very similar. So it depends on the students. For electrical engineering students, it's easier because they worked with microcontrollers before. But for computer science students, where this hardware stuff is very, very new, we will still use Arduino just for the first 2 labs roundabout that, so that they get in contact to the controller. They had the Hello World Blinky project, and then we will continue with Zephyr as a more professional tool framework.
Have you tried using MicroPython to replace the Arduino stuff?
I haven't. I know my colleague was working with MicroPython.
Maybe I can continue to answer. Because our study program is changing a little bit. I started with computer science students doing both together. So starting with half a semester C, Mbed OS, Zephyr, and the second half, because the computer science students are very good in programming Python, so we used CircuitPython there, because CircuitPython is a little bit easier, because USB is like a flash drive, and they can use an editor and write their Python scripts. And in the future, we will divide that, because then we have Embedded Systems 1 and Embedded Systems 2. So Embedded Systems 1 will be plain C, C++, also for computer science students. And Embedded Systems 2 is only Python.
And so you're using the Platform.io VS Code plugin as an environment, right, for the students?
Yes.
What experience have you made with that?
A very good experience. The setup was easy. All the functions like debugging, flashing, they work seamlessly. We didn't have any major problems, actually.
So if any problems come up, you can use our container environment.
Yes, I followed. Yeah.
You don't use Westband at all with Platform.io, right?
No.
I assume that that's abstracted away, right?
Yes,
It is, yeah.
It's internal. It's the internal.
There's no contact for the students with that. Yeah.
Maybe one sentence for that. So I started with Platform.io last winter semester, because summer was the message, Mbed is dead, and I had less than 4 weeks to change something. And I want to have something where I can use all 3 things. Platform.io can create Arduino projects, Mbed OS projects, and Zephyr projects. That was the reason with the same starting page, where you choose what you want and you get a basic running compilable project, and that was the reason for Platform.io. And the installation is very easy. You choose Arduino and all the stuff is installed. You choose Mbed OS, the compilers, the libraries is installed. So it was very easy and nearly no problems. And the students had their own notebooks.
Yeah. Okay.
But we don't have so many students like you have. We have just 2, 3 handfuls, not more.
If I can comment, if you can hear me, actually,
can hear you.
we are using Platform.io as well in Prague as the default lab environment for students, because they are mostly used to Visual Studio, so it's comfortable for them, and flashing the device, etc., it's easy. So it's not, and as you said, they can switch the Arduino, Zephyr, whatever they want.
Okay, thank you. Any more questions? Doesn't seem to be the case. Thank you very much again for the
Thank
talk.
you.